Today we'll practice writing the subcell configuration of some elements. The main purpose to read subcell in this lesson is to know how to express the subcell configurations of different elements, especially first 20 elements from 1 to 20, from hydrogen to calcium. So in addition, we'll talk some extra and some exceptional case also. But the major is you must know to accommodate the electrons of first 20 elements on the basis of subcell. Okay, for hydrogen 1s1, for helium 1s2, like that. So let's begin. सुरु गरौँ class 10. For this, let me share the slide. Here, the lessons we are going to read. We are reading is classification of elements, unit 7. From last class, we have started reading this chapter. Okay, let's review for 1-2 minutes. The major portions that we are going to read in this lesson are periodic table, subcell, properties of groups and periods in the periodic table. These are the topics. You can get this PDF file later on. I will share in the Google Classroom. So from there you can see the topics, and we'll go through. Okay, first a subcell. After completing that, then we'll go to another topic, periodic table. Then finally, the last portion, properties of groups and periods in the periodic table, and we'll review just by discussing the questions which can be asked in the exam. In the picture, you can see the different that the atomic structures. So this is the history, or let's say evolutions that done by different scientists. So assumption and the reality means by the observations. So the the front atomic structure, so which you can see here, that green in color, the latest observations of the atom, which shows atom is positively charged nucleus surrounded by a cloud of negatively charged electrons. So in the beginning, when the scientists they found they study about atom, they did not know anything about subatomic particles. So they didn't have idea about proton, electron, neutron, like that. Later on, Johnson, okay, he just assumed that the positive charge and negative charge are found just like the seeds in the watermelon. And later on, it is found that there is central part in an atom which we call nucleus. And further, the study is done and found the center nucleus is surrounded by electrons which are found in the orbit. Now we are saying that the electrons are continuously spinning, so by which they appear as cloud. So we can say electrons are negatively charged particles, so which are surround or revolve the nucleus in the motions and form a cloud-like appearance. Okay, so now, okay, recently the atom is defined as the positively charged nucleus surrounded by negatively charged electrons cloud. And then next, as subcell, the first portion that we are going to discuss. In the last class, so we discussed many things about subcell. To know about subcell, we also have, or we also must know the terms like cell and orbital. Cell is the region around the nucleus where we find the electrons are revolving, and inside the cell, or let's say cell consists of the small regions, so which is a group of orbitals, and that is called subcell. So orbitals are the smallest regions where we find the probability of electrons existing is maximum. Means the real region, okay, around the nucleus where the electrons are found is orbital. And we also talked that there are 4 subcells. They are symbolized S, P, D, and F. So the main purpose of reading subcell in class 10 is to know how to accommodate electrons of elements on the basis of subcell. And to write a subcell electronic configuration, our students must have basic knowledge. And the basic knowledge for knowing the number of electrons that can be accommodated in different subcells is you must know that how many subcells or which subcells are found in different orbits of an atom, in different cell of an atom. So in K cell, only one subcell exists, that is S subcell. And in second cell of atom, we find 2 subcells, S and P. Likewise, in third cell, there are three subcell S, P, and D. And finally, in number four, fourth orbit cell, there are four subcells S, P, D, and F. So this is the basic knowledge. And since I said that subcell, okay, is let's say comprised of orbitals, means subcell is a group of orbitals. In S subcell, there is only one orbital, that is S orbital. But if you go to P subcell, then we find three orbitals. They are Px, Py, and Bz. And each orbital can accommodate only two electrons. And since P subcell has three orbitals, that means P subcell can accommodate 6 electrons, right? Because in Px there we can accommodate 2 electrons, Py2, and then Pz 2 electrons. Like this, P subcell can accommodate maximum number of electrons, and that is 6. And in D subcells we find 5 orbitals like dxy, dyj, dzx, dx square minus y square, and then dz square. Here S subcell, okay, symbol S that we write in small letter, small s, small p, small d, it names sharp, S names sharp, and P is the acronym of principal, D for diffuse, F for fundamental. सुनिराख है, बुझ please. And in S subcell, that the number of electrons that can be kept is 2. This is the maximum number. And in P subcell 6, diffuse D is 10, and finally F subcell 14. So in S subcell we find 7 orbitals. S only has one orbital, that is named S orbital, P3 and D5 and F7. So in F subcell we can accommodate 14 electrons. So after this, then how do we represent the cell or subcell? And cell of an atom is represented by, okay, letters in capital like K, L, M, N, and the principal quantum number, or the number for the cell of an atom is as first for 1, and then L for 2, and 3 is for M, means third cell, and fourth orbit is, that is N. And in case of subcell, so if we are representing the subcell of first orbit or first cell, that is K, okay, that in small n1, we write 1s. So 1s means that is the subcell belongs to first cell of an atom. And for second cell subcell, so we write 2s and 2p. So 2 here, okay, the number or the coefficient here represents the cell of an atom. Okay, 3s, 3p, 3d means, okay, these are the subcell of a third orbit of an atom. So you understood this one. And there is one principle, another basic knowledge that we have, okay, we must have knowledge. So when we are going to write the electronic configurations of elements on the base of subcell is a principle. So there is some order. Okay, so how do we write the order of subcell while writing the configuration? And order is always that is from lower energy level to higher energy level. So in an atom, the filling of electrons occupy in the increasing order of energy level. That means at first the electrons get filled in lower energy, that means first orbit, and then if there are more electrons, then they go to second and third, like that. But when you talk about subcell, then in all atoms, the first electrons get filled in 1s, that is the subcell of first orbit. Then next comes 2s, twice p. Okay, there is a diagram you can see that represents the above principle. That is the order of filling of electrons in subcell. Okay, in 3s and 3p. And though 3d is the subcell of third orbit of an atom. Now, if there are more electrons, okay, in bigger atoms, then the electrons first get filled in 4s. Then only the left electrons fill in 3d, because 4s subcell is lower energy level than 3d. Okay, so for first 4s subcell is filled with electrons, then only turn comes up 3d. So these are order 1s, 2s, twice p, 3s, 3p, 4s, 3d, then only 4p. Okay, it goes like this, 5s, 4d. So this is above principle. So after knowing the number of electrons that can be accommodated in different subcells, okay, like 2, 6, 10, 14, then upper principle, now we can easily mention or write the subcell electronic configuration of elements. Then how to express, so how to write, how to mention. So there is the rule. You can see one formula, okay, on your screen. There's stress, that is n x to the power e. So where x, that represents subcell, there can be s, p, d, or f. X represents subcell, and in front of x you can see the symbol n, that represents the number. Okay, the number of cell orbit. Which orbit? First orbit 1, second orbit 2, okay, for third orbit 3, like that. And that x to the power e, that e represents the number of electrons. As for example, this above picture you can see 1s1. So this is the subcell configuration of hydrogen atom, and here s is orbital or subcell, and then the 1 in front of s, that is the number of orbit, that is the first orbit of hydrogen atom. And then power 1, okay, s to the power 1, and that 1 is number of electron, right? So hydrogen atomic number is 1, means that there's only one electron. So one electron can be easily accommodated in first orbit, and first orbit has s subcell. So 1s1, 1 first orbit, then s subcell of first orbit, and power 1, that is the number of electron. So hydrogen has only one electron, so is the power 1, 1s1. Okay, for other atoms, you can see here as examples. Please try to understand. Okay, there are 4 examples of elements: nitrogen, chlorine, potassium, iron. And atomic number of nitrogen is 7. So once we have idea of let's say name of elements and their respective atomic number. So atomic number means the number of electrons. Then we can easily do the subcell configurations. So we already have a different basic knowledge how to write and how to express the subcell configuration. For example, atomic number of nitrogen is 7. Then we have to start from the first orbit. First orbit has s subcell, and if electrons are left, then we go to second orbit. Then for second orbit we have s subcell and p subcell, like that. So here for nitrogen, subcell configuration is shown as, okay, 1s2. So altogether there are 7 electrons in nitrogen. So 2 electrons, so we kept in, okay, subcell of first orbit, so it is 1s2, and still 5 electrons are left. So we get another subcell of second orbit, and in subcell for second orbit, always in between s and p, s comes first because s is lower subcell than p. So 2s2, then 2s2. So s subcell can have maximum 2 electrons. Okay, you cannot keep 2s3, 2s4, like that. Maximum 2. So 2s2, still the electrons are left. And then how many electrons are left? 3. And then we have 2p3. Okay, 2p3. And maximum electrons we can keep in pure subcell is 6. So it is just 3. So it is where 1s2, 2s2, 2p3 is the subcell configurations of nitrogen. Okay, and I request all the students, please to note down this in your copy. Please go on writing. Right? And to know the number of electrons, so when we are given subcell configurations, simply please add the power. It's like S1s2, 2s2, 2 plus 2, 4, and 2p3 plus 3, 7. So total number of electrons, okay, according to the subcell, is 2 plus 2, 4, 4 plus 3, 7, and it is nitrogen atom. So when you are given name of or symbol of elements and asked to write the subcell configuration, so you can do that by the basic knowledge and then by our principle. But sometimes when the question is like that, you are given the subcell configuration, then you have to identify the elements, corresponding elements. And for that, you can simply add the power and get the total number of electrons, which represents atomic number. And number 2 is chlorine there. Cl, whose atomic number is 17, means in neutral case, the number of electron of an atom is always equal to atomic number. So atomic number 17 means electron number is also 17. So we have to accommodate 17 electrons of chlorine on its subcell, and always it starts with 1s. So 1s2, 2s2, then more electrons are there, 2p6, still electrons are left. Then we go to another, subcell of third orbit, because second orbit has only two subcell, 2s and 2p. After that, we go to 3s2 and 3p5. So altogether 17 electrons. So in chlorine atom, so 1s2, 2s2, 2p6, 3s2, 3p5. If the subcell configurations of chlorine. Got it? बुझ्दैछौ क्लास 10? कपीमा लेखिरहेछौ? अहिले म छुट्टै एउटा क्वेसन दिन्छु, त्यसको तिमीले प्र्याक्टिस गर्नुपर्छ है, अनि एन्सर भन्नुपर्छ प्लिज. नम्बर 9 पोटासियम, यसको एटमिक नम्बर 19, means electron also 19 number. अब यसलाई एकोमोडेट गरौँ on basis of subcell. So always starts with 1s, that is subcell of first orbit, 1s2, then 2s2, 2p6. Second cell मा दुईटा मात्र subcell, 2s र 2p, and 2s मा 2 maximum, p मा 6 अझै इलेक्ट्रोन बाँकी छ. So we go to, that is third. And 3s2, 3p6 फिल भएपछि पनि इलेक्ट्रोन बाँकी रहेछ अझै, तर हामीले 3d ले गरेनौँ. ओके, किनभने 3d भनेको 4s भन्दा के छ, हायर एनर्जी छ. अब प्रिन्सिपल अनुसार के गर्नु पर्यो त, फर्स्ट लोअर एनर्जी गेट्स फिल्ड, देन ओन्ली इट गोज टु हायर एनर्जी भयो. तर 4s मा 4s1. Okay, so when we draw atomic structure of potassium, so we draw 4 orbits. I mean nucleus draw गरेपछि फर्स्ट अर्बिटमा 2 and second मा 8, third मा 8 गरेर लास्टमा 4 गरेर गर्छ, 1 गर्छ. So 2 8 8 1 गर्छ. And this is let's say another, that is D block elements, iron. Iron को atomic number 26 छ, बुझ. अनि 26 atomic number भनेको यसको इलेक्ट्रोन पनि 26 छ. अब यसलाई सबसेल कन्फिगरेसन गरेर देखाउनु पर्यो. यसको पनि सेम प्रोसेस, 1s2, 2s2, 2p6, 3s2, 3p6, यहाँसम्म क्लियर छ. अनि 4s2, अनि 4s2 भएपछि अझै पनि इलेक्ट्रोन बाँकी भएको भएर अनि अर्को 3d मा गयो, अनि 3d मा 6 भयो. All together, so how many electrons are there? So we find when you get the total of power in subcell, that 26 bio. So this is the correct subcell configurations of iron atom. बुझिन्छ है? अब मलाई यसलाई अर्को तरिकाले देखाउँछु प्लिज. Here please. So number 11 is sodium. So we had pre-knowledge that we used to do electronic configurations. On the subcell, 8-1. First orbit 2 electrons, second orbit 8 electrons, and 1 electron in third orbit. ल सानो एउटा सानो क्लास अफ दिन्छु है त, जस्ट फर 1 मिनट. तिमीलाई अक्सिजन भन्ने एटमको सबसेल कन्फिगरेसन लेखेर भन त, ल मैले भने गर्न सक्छौ. अक्सिजन एटमको सबसेल कन्फिगरेसन आफ्नो कपीमा लेख अनि एन्सर भन त कस्तो हुन्छ. अक्सिजन, you know the atomic number of oxygen 8. Okay, means it has 8 electrons. त्यो 8 वटा इलेक्ट्रोनलाई बाँड्ने त हो नि, डिस्ट्रिब्युट गर्ने, सबसेलमा डिस्ट्रिब्युट गर्ने हो. डन. Okay, done. Please, what? Yes, thank you. What is the answer?
So 1s2,
2s2, 2p.
Okay, म सबैको एन्सर सुन्छु. सेम एन्सर भयो भने म सबैको सुन्छु पाले पाले. जस्तै 1s2, 2s2 अनि 2p.
2p4.
Very good. Yes. Oh, 1s2, 2s2, 2p. Right. ल मिल्यो. त्यसो भए अर्को एउटा एटमको दिन्छु ल. एल्युमिनियमको. एल्युमिनियम नम्बर 13 एटम.
1s2, 2s2, 2p6, 3s2 and 3p1.
Very good. Excellent ल. हेर त यो मोलिब्डेनममा पनि ओके यसो केस हुन्छ. जस्तै यहाँ 4d5 5s1 छ लास्टमै. ओके, हुन पनि 4d4 5s2 हो नि. ओके, तर 5s1 भएर 4d5 भयो. अनि सिल्भरमा पनि केस, सिल्भरको एटमिक नम्बर 47 हो. ओके, यसको इलेक्ट्रोन्स डिस्ट्रिब्युट गर्दाखेरि चाहिँ अब लास्टमा आइपुग्दा के हुन्थ्यो भन्दा 49 5s2 हुन्थ्यो, तर करेक्ट के हो त 4010 5s1. त्यस्तै गोल्डमा पनि हेर्न सक्छौ. यो गोल्ड सिल्भर भनेको त अब कपरमा पनि त्यस्तै थियो नि, कपर सिल्भर गोल्ड यो एउटै ग्रुपमा पर्छ पिरियड टेबलको. तर यो नोबल मेटल्स हो, सबैको एउटा क्यारेक्टर सेम छ र दि. ल गोल्डमा के हुने हो 5d10 6s1 हैन. कपरमा के थियो 3d10 ओके 4s1 थियो. सिल्भरमा आयो 4d10 5s1 भयो. अनि गोल्डमा के छ 5d10 6s1 भयो. ओके 1111 छ. एनीवे यो एक्सेप्सनल केस भयो. ओके अब रुल अनुसारको इलेक्ट्रोनिक कन्फिगरेसन्स अन द बेस अफ सब सेल त हामीलाई आइहाल्छ अब 1 देखि 20 सम्म कुनै पनि एलिमेन्टको कन्फिगरेसन गर अन द सब सेल भन्यो भने यु नो अब हजुर
सर त्यो अघिनको त्यो क्रोमियम अनि अरू त्यो कपरमा चाहिँ किन प्रिन्सिपल अनुसार नलगेको
त्यो प्रिन्सिपल अनुसार किन भनेको त मेन थिङ भनेको त एटम्स हाम्रो नेचरमा पाइने हो राइट अनि एटम्स नेचरमा पाइँदाखेरि त्यसको इलेक्ट्रोन्सहरू कसरी बस्छ सबसेलमा राइट अर्बिटमा कसरी बस्छ भन्दाखेरि अनि एउटा केस के हुँदो रहेछ भने त्यो अब्जर्भेसन गरेर हेर्दाखेरि ओके 3D 9 हुँदा हुँदै पनि त्यो 9 को ठाउँमा एउटा इलेक्ट्रोनाइट हुँदा 10 हुन्छ अनि जब कुनै सबसेल कम्प्लिटली फिल हुन्छ नि अनि त्यो बेलामा त्यो स्टेटमा चाहिँ एटम्सहरू के हुन्छ त एक्जिस्ट हुन्छन् भन्ने भएर ओके रुल अब पत्ता लागेको अनुसार रुल त हामीले बनायौँ भनेको अब प्रिन्सिपल आयो हामीले त्यही फलो गऱ्यौँ तर जब नेचुरल्ली हामीले चाहिँ एटमको केस हुँदाखेरि चाहिँ कपर क्रोमियमको केसमा चाहिँ फुल फिल र हाफ फिल हुँदाखेरि त्यो त्यस्तो स्टेटमा पाइने भएर अब त्यहाँनिर 3D 9 4s2 भएन त्यहाँनिर के भयो त 3D 10 अनि 4s1 भयो है भनेको मतलब कस्तो भने त्यो एटम्सले चाहिँ त्यो अब प्रिन्सिपलको जुन रुल छ त्यो फलो गरेन भन्ने हो नेचरमा के पाइँदो रहेछ त 3D 9 4s2 होइन कि 3D 10 4s1 पाइँदो रहेछ अब अरू एलिमेन्ट्सको लागि चाहिँ त्यो रुलले पुरै के भयो अबे गर्यो होइन जे छ एटम्सको कन्फिगरेसन त्यो अनुसारको रुलले भनेको अनुसार नै भयो तर त्यसमा चाहिँ अलिकता छुट्टै भयो भनेको त्यो एक्सेप्सनल भयो भन्ने बुझिन्छ
यस सर
ओके अब हेरौँ है क्वेसन हो क्लास 10 यो अहिले तिमीले स्क्रिनमा देखेको चाहिँ क्वेसन हो अब तिमीले यो कन्फिगरेसन हेरेर एटम्सको नाम भन्नु पर्यो है 1s2 2s2 2p6 भनेछ ल है फर्स्टमा कुन एटम होला क्लास 10 भन त प्लिज
नियन
यस नियन भेरी गुड यस ओके अनि सेकेन्ड एटम छ 1s2 2s2 2p4 कुन एटम होला
Oxygen.
अक्सिजन भेरी गुड 1s2 2s2 2p6 3s1 छ दिस एटम
सोडियम
अनि नेक्स्ट नम्बर 5 मा 3s2 3p5 मा क्लोरिन भेरी गुड अब नेक्स्टमा हामी जाउँ 4s1 छ नि लास्टमा कुन होला यो
पोटासियम
अब सेकेन्ड लास्टमा 3s2 छ नि लास्टमा कुन होला यो एटम म्याग्नेसियम भेरी गुड अनि लास्टमा हामीसँग अझै 4s2 छ लास्टमा फोर्थ अर्बिटको s2 ओके क्याल्सियम हो अब हेर यो इलेक्ट्रोन्स जुन हामीले डिस्ट्रिब्युट गरेका छौँ सबसेलमा ओके अब यसले धेरै कुराहरू भन्छ हामीले त सिम्पली के जाने भने एटमको एटोमिकमा थाहा छ इलेक्ट्रोन थाहा छ भने अब सबसेलमा कसरी इलेक्ट्रोन्सहरू डिस्ट्रिब्युट भएर बस्छ भन्ने कुरा अहिले जान्यो होइन अब सबसेल इलेक्ट्रोनिक कन्फिगरेसन जानिसकेपछि अब यसबाट पनि हामीले धेरै कुरा थाहा पाउँछौँ त्यसमध्येमा चाहिँ अब यो एलिमेन्ट्सहरू पिरियड टेबल कुन चाहिँ ब्लकमा पर्छ पी ब्लकमा हो कि एस ब्लकमा हो कि डी ब्लकमा हो कि एफ ब्लकमा हो भन्ने कुरा हामी सबसेल कन्फिगरेसनबाट थाहा पाउँछौँ जस्तै माथिको हेर सुरुको फर्स्टमा 1s2 2s2 2p6 छ नि अब त्यसमा हेर्दा सबैभन्दा लास्ट सबसेल आएको के छ पी छ अब यसको मतलब यो नियन भन्ने एलिमेन्ट चाहिँ पिरियड टेबलको पी ब्लकमा हुँदो रहेछ जस्तै मैले थर्डमा भने 1s2 2s2 2p6 3s1 छ अनि त्यो 3s1 भनेको लास्टमा सबैभन्दा पछि आएको जुन सबसेल त्यो एस छ राइट अनि त्यो एस सबसेल भनेको मतलब अब यो एलिमेन्ट चाहिँ कुन ब्लकमा छ त एस ब्लकमा छ अब एस ब्लक के हो पी ब्लक के हो म तिमीलाई देखाउँछु है त ल यहाँ हेर अब यो मैले एउटा पिरियडिक टेबल सो गरेको छु स्लाइड है तिमीहरूको स्क्रिनमा देखाएको छ होला अब यसमा यो जुन ग्रुप फर्स्ट र यो ग्रुप सेकेन्ड जुन छ 1 र 2 लेखेको छ माथि मैले रातोले चिन्ह लगाएँ यो दुईटा ग्रुप चाहिँ एस ब्लक हो भनेको पिरियडिक टेबल है मोडर्न पिरियडिक टेबल इज डिभाइडेड इन्टु 4 ब्लक्स अनि यो फर्स्ट जुन दुईटा ग्रुप छ यसलाई चाहिँ एस ब्लक भनिन्छ भने अब यो राइटमा गयो भने ओके यो 13 देखि यो 18 सम्म यो छ यो हेर त यो ब्लक यो ब्लकलाई चाहिँ पी ब्लक भनिन्छ अनि त्यसपछि यो बिच जुन छ यो एस ब्लक र पी ब्लकको बिचमा जुन छ यो भनेको 3 देखि 12 सम्म जुन छ यो ब्लकको नाम हो डी ब्लक अनि लास्टमा एउटा छुट्टै यहाँ सेपरेट गरेर राखेको छ ओके यो ब्लकको नाम हो एफ ब्लक यसरी 4 ब्लक्स हुन्छ है मोडर्न पिरियड टेबलमा एस ब्लक पी ब्लक डी ब्लक र एफ ब्लक अब तिमीले के पाउँछौ भने यो पी ब्लकमा हुने कुनै पनि एलिमेन्टको एउटा हिलियम चाहिँ एसोसनल हो ओके हिलियम चाहिँ त्यो ग्रुप 0 मा राख्न पर्ने भएर लास्टमा राखेको हो अनि यो हिलियम बाहेक अरू सबै एलिमेन्ट्सको तिमीले सबसेल कन्फिगरेसन गर्यो भने त्यो सबै एलिमेन्टको लास्ट इलेक्ट्रोन कुन चाहिँ सबसेलमा फिल हुन्छ त पीमा हुन्छ अब तिमीले यही चेक गर्यो भने पोटासियमको हेर सोडियमको हेर क्याल्सियमको हेर म्याग्नेसियमको जति पनि यो फर्स्ट र सेकेन्ड ग्रुपको चाहिँ एलिमेन्ट्सको कन्फिगरेसन हेऱ्यो भने त्यसको लास्ट सबसेल के भन्छ त एस सबसेल हुन्छ र सबसेलको आधारमा सो वी क्यान ह्याभ 4 टाइप्स अफ एलिमेन्ट्स है पिरियड टेबलमा त 4 ब्लक्स भइहाल्यो साथसाथै अब एलिमेन्ट्स पनि कति टाइपको हुन्छ त भन्दाखेरि 4 टाइप्स राइट यो 4 टाइप्सको एलिमेन्ट्स चाहिँ के त म यो पछि आउँछु यो स्लाइडहरुमा राइट एउटा हो एस ब्लक एलिमेन्ट्स हेर त एस ब्लक एलिमेन्ट्स 1 मिनेट है क्लास 10 so on the basis of subcell we can classify elements into 4 types. The first one is s block elements and s block elements भनेको के हो त भन्दाखेरि whose last electron filled in s orbital अथवा s subcell. अनि in MPT भनेको मोडर्न पिरियड टेबल भनेको यसलाई चाहिँ यो MPT मोडर्न पिरियड टेबलमा चाहिँ त्यो ग्रुप फर्स्ट र ग्रुप सेकेन्डमा भएको जुन एलिमेन्ट छ they all are s block elements. Okay, their last electrons are filled in s orbital or s subshell. Like second our arco type elements are that is p block elements, and in p block elements the last electrons are filled in p orbital or you can say p subshell. Subshell भनेकै orbitals को collection हो right, तर subshell र orbital कहिले कहिले सँगसँगै भनिन्छ यसमा कन्फ्युज हुनु पर्दैन है slightly different भए पनि that p orbital भन्नु नै केलाई भन्न खोजेको त subshell ला भन्न खोजेको p subshell ला भन्न खोजेको right. So p subshell मा p orbital मा last electron fill हुन्छ भने those elements are called p block elements right, and p block elements are located at the right side of the periodic table. हामीले मोडर्न पिरियड टेबल हेर्यो भने राइट साइडमा के हुन्छ p block elements छ अनि त्यस्तै गरेर थर्डमा छ so we have d block elements यो जुन अघि बीचमा हामीले देखाएको थियौ नि है s र p को बीचको जुन चाहिँ ग्रुप अफ एलिमेन्ट्स थियो 3 देखि 12 सम्मको यो d block elements these are also called transition elements किन्तु s block मेटल हो राइट अनि p block के हो त p block मा सम के मेटल छ तर म्याक्सिमम के छ नन मेटल छ हेलोजन नन मेटल हो ओके तिम्रो चाहिँ अक्सिजन भएको ग्रुप नन मेटल हो अब लास्टमा ग्रुप 0 सबै नन मेटल हो भनेको मेटल जुन छ ग्रुप फर्स्ट र सेकेन्ड भनेको जुन रोमन नम्बर a ia बाट तिम्रो ia भनेको 30 मा जाँदाखेरि के भएर जानु पर्छ त यो d block भएर जानु पर्छ. So this lies between s block and p block. So these are also transition elements. And यसको लास्ट इलेक्ट्रोन कहाँ फिल हुन्छ त भने d subshell अथवा d orbital मा. Lastly जाउँ हामी f block मा. So f block elements